2 out of 3 in this beautiful times of 2020. The start of it is, of course, about the subject what we all have come up with here, namely learning, sharing. And it's a big pleasure having Connor McDonald from Oracle Corporation with us today. He is not just one Oracle employee, he is one of the guys who's advocating for everyone out there. So within Oracle, his role is special. He's part of the Ask Tom, the Oracle Masters, and that means he is very vocal about what can be done, what should be done. His session today is about what can be done and should be done about learning. I grabbed for him one of those things which is of relevance, namely learning is no spectator sport. And I think with that, it's probably the best time to listen to Connor himself, allowing him to share what we should do to share better, to be more efficient, as well as in making it happen. It's up to us to share. Connor, stage is yours.
Good morning, everyone. It's good afternoon for me, but thank you very much for jumping into work early to come visit this fantastic series of presentations we've got going on for the Swiss Oracle User Group today. Let me share my screen and we'll get straight into it. Okay, hopefully you can see me, hopefully you can hear me, and hopefully you can see my screen without too much difficulty. So my name's Connor McDonald. I come from Perth, and for those who haven't been to Australia, that's on this side of the world. Thankfully, it's the opposite side to where the most harsh lockdowns have been occurring in Australia. Speaking of lockdown, I'll throw this slide up there, not to paint a gloom and doom picture of across the world, but more the fact that this is a community event. We're part of a user group here, and we're always talking about having our communities prosper, have them succeed and be successful with the Oracle database. Communities only work if there's actually people in them. So please follow your local guidelines, your local laws, and stay safe, stay healthy, because we'd love to obviously meet face to face one day. I must start with an apology, because last year I got asked if I could come to the Swiss Oracle user group, and I couldn't, but I said next year I promise. And of course things changed a bit, and so the best I can do this year is to come virtually, but hopefully we'll be able to get there face to face next year. This is how you get in touch with me. I'm best is probably on Twitter. I love talking tech. I have a blog as well. I have a YouTube channel, but all you really need to remember is the Twitter handle, which will be at the bottom of the slides throughout this talk. Yeah, please reach out, follow me, and we can talk tech whenever you like. So why talk about, I call it the fast lane to database expertise, as in not having to learn everything from scratch. And why would I talk about this? The best way of describing it is to talk about an experience I had on Ask Tom. And you don't have to read all of that. This was the question that came in. How do you pass a parameter to a view? And we won't discuss exactly what I said to them, but I gave them an answer. And they came back with a comment. They said, how did you know that answer? How did you work it out? And it was one of those things I'd had to work out years in the past, and it just sort of was stuck in my head. So I said, it's hard to explain how I knew the answer. At some stage in the past, I must have worked it out. I said, it's just experience. And they then replied back with a comment, and they said, well, we think you're an asshole. So that was what prompted me to give this talk today, in the sense that, I'm hoping that response I gave, didn't make me out as being a bad member of the community. I hope not. But I think the big thing that we fall into the trap of nowadays is there's the occasional person out there on the community who we would perhaps describe as lazy. They don't knuckle down and do their own research, and therefore they always get answers from the Stack Overflows and the Ask Toms, etc. But I think we've shifted too far to criticize these people. The most common thing I see on forums nowadays is people respond with RTFM, or let me Google that for you, or go check in the docs, etc. I don't think everyone should have to reinvent solutions to problems that have already been solved. It really shouldn't be always that we're responding with RTFM. What is the definition of a great tech community? It's about sharing our knowledge. It's about coming together. If I have a solution to a problem, I shouldn't be downgrading someone else and tell them that they have to work it out for themselves. I should always share that. Then together we grow as a community. So that's why I wanted to do this session on just little quick tips and techniques that I've picked up over the years, of which there are many to count, such that you don't have to solve these problems yourself. They'll just go into your toolbox. You may never use them, but you might find them useful. You can share them with your work colleagues, and that way we all prosper as a Oracle community. Some of the things you'll see in this presentation are not straight out of the manual, so I've put the old safe harbor statement up there. And don't forget, I'm from Australia. It's a place where the world used to send all its convicts and criminals. So don't trust anything I say. I'm descended from burglars and thieves and the like. So if you can't find anything I say today in the documentation, before you go and throw that into your production system, contact support and get a clarification to make sure that they endorse you using it. That's to cover me, and more importantly, to cover yourselves, to make sure you don't do any damage to your systems. For the rest of this time, we're just going to smash through as many as we can, and in the time we have available. So the first one is dealing with a rogue session. And what I mean by a rogue session is we all have that database where we, from time to time, we get an alert, and there's something like this going on. Session number 39 has been active for 7,376 sessions. And the funny thing is, generally it's not that session, that person who actually gets upset. The problem is because they're hogging all the resources, other people that would normally be getting their work done almost sub-second are actually slowing down. We can see session 46 has been running for 12 seconds, 51 for 9 seconds, etc. These are the people that get on the phone saying, why is the server running so slow? And of course, in the old days, you'd be fast asleep at night as a DBA, and one of these things would beep. We used to call them a pager. And you'd get little, signals saying there's an idiot in the database. Obviously, things are modern nowadays. We don't have pagers anymore, but the technology has changed, but the response is the same. It just comes on your cell phone nowadays. What we would do is we'd crawl out of bed, we'd do alter system kill session or kill -9 at the OS level. The problem is that gets everyone upset, because that person who was running something for perhaps 2 hours might have been on the cusp of just about being able to finish their big long running report. They knew it was going to take a long time. They set it going before they went home, etc. They wanted it to finish. And they'll be on the phone to you saying, why did you kill my session? I'm just going to have to run it again. Wouldn't it be good is if we could just grab that session that's causing the problems and tell that person to back off a little bit? And this is one of the little tips you can do. Using oradebug, you can connect to that process using setorapid NNN. That's the Oracle process ID you get from VDOLA process, and you can suspend it. What that does is session 39 literally is now frozen. They stop doing I/O, they stop using CPU as long as they're not stuck in a spin. But in normal Oracle operations, they are simply frozen in time. They stop consuming resources. As a result, these other sessions you can see in green will actually finish their work. They now get a slice of the server pie. Once that sort of critical time has passed, you can now do oradebug resume, and that session continues on. They will have run for maybe a couple of minutes longer than they would have expected, but if they've already been running for 2 hours, they won't even notice. But notice no one had their session killed, and it's a nice, easy way of averting a crisis without getting people upset with you. Obviously, if this was happening regularly, you would use something like Resource Manager to actually control the division of resources on the server. But for those one-off things, suspending and resuming a process sometimes is a quick get-out-of-jail card to help you utilize your server resources. Number 2, you get an idea of what we're just going to crank through as many as we can. Maybe it's not bad SQL that's causing a session to be running for that long. Even though that session is set as active, maybe they're not using any SQL any resources at all. Maybe the problem is if I change my query to see, are they stuck on a lock? Maybe this is perhaps the real scenario here. They've been running for 2 hours, not because they're busy, because they're waiting on a lock. And we can actually dig a little bit further using the blocking session columns to actually find out what the problem is. And we can see that session 46 in this case is blocked by session 39. And session 46 is trying to do select star from T for update. So session 39 is one of those people that started the transaction and gone to lunch, or an application server process has crashed, etc., leaving a lock floating around in your system. This is something that came in way back in Oracle 9, yet I still so rarely see it used. We can actually nominate a timeout now on select for update. When I say now, I mean for the last literally 15 years. And the good thing with that is now, rather than waiting forever, you actually will wait for up to 60 seconds, and then it'll actually come back with ORA 30006. You've actually timed out. Now, what's really the difference? I mean, we still had an error. We still didn't get any work done. The main difference is, in computing terms, forever is a long time, because the moment you have one person stuck on a lock, we all know as DBAs, that can just crescendo out to being a site-wide disaster. Here's session 39. He's been inactive now for 5 minutes or a little bit more, 370 seconds. He's got a lock, but he's inactive. Session 46 gets stuck on session 39. And if it's select for update with no timeout, they're stuck. And so is session 56, and so is 58. But because these sessions are now stuck, they may have their own locks taken out so far. So now 62 is blocked by 46. And so is 63, 67, 71, and then 76 is blocked by 62. You get this very quickly cascading scale of people all getting locked. Ultimately, they're all stuck on this person. And if we simply use select for update with a wait clause, we avoid these sort of cataclysmic conditions. The other nice thing is it's a different error message. Normally when you do select for update no wait, you'll get ORA 54. Select for update with a wait returns you 3006, so you can explicitly track it. One of the things I like doing is putting a DDL trigger on my database saying if I get a server error and it's session 006, I'll try use VDOLA session to go look up, for example, who's causing that problem. Go look up, for example, the OS user column for session 39, the person that was causing the block. And that way I can actually put that in the error message. So now when this person times out, not only do they time out and therefore not get stuck waiting forever, we can actually tell them, hey, Connor on extension 1234 is the person that's causing you grief. I call that empowering the users. No DBA intervention required, because your users will quite happily take care of it themselves. I'll phone that person up and say, go back to your machine and get rid of that blocking session. Number 3, triggers. I'm getting old. I'm well into probably the second half of my life, and my coding skills are generally, getting a little bit rusty. And so when I have to write triggers nowadays, I generally write triggers a bit like this. It sort of looks okay. What I'm doing is I'm checking the salary on a Monday. So every time I do something on the employee table, I say, if the salary is greater than 20 and it's a Monday, then I'm going to raise some sort of error. And it looks fine until I try and compile it. And the first thing I got wrong was I didn't spell updating right. I put an E in there. So as we all do as developers, I fix that error and compile it again. I didn't put a colon in front of the new. So that's another compilation error. So I fix that and I compile it again. That end is wrong. It should have been end if. And so eventually, after all this time, it finally will compile. This goes on and on and on and on. The fundamental problem, and this is different to almost anything else in terms of the database, is when that trigger won't compile, I have killed the table that trigger is on. It literally is dead in the water, because any kind of DML I try to do, in this case just an update, where 7365, it says the trigger is invalid and has failed re-verification or revalidation. Triggers create incredible sensitivity problems inside your database, because if the trigger is invalid, literally you have busted that table. And it really is all DML. And to explain what I mean by all DML, here's an example where I try to do an update for employee number equals 7365. I get the same error. Trigger is invalid, but there wasn't even an employee with that number. It's not as if you have to go find a row and therefore start updating it and then the trigger will fire. Even if this update would have done nothing, the very fact that the trigger is broken breaks my table, dead in the water. What I like to do is, as a coding standard, is enforce what we call disabled triggers, which means have a coding standard in your organization, which means whenever you create a trigger, it's always created in an initial mode of disabled. That way, if it doesn't compile, your table is fine. Yes, the trigger's not there, but you haven't broken the table. Number 4, tracing. Tracing is one of those fantastic tools, and it's such a great thing to see that over my lifetime as an Oracle practitioner, it used to be a couple of DBAs would use it, then all DBAs would use it, and now we're into the world where developers are clamoring to use it. They're always asking the DBAs, can we get access to the trace facilities, because it's such a good performance monitoring facility. We do alter session set SQL trace equals true, or we do DBMS monitor session trace enable, or there used to be DBMS support, or if you're a geeky, you can do alter session set events 10046, etc., etc., etc. But as it gets more popular, what you end up with is this kind of issue, where yes, now everybody is creating trace files. There are simply too many trace files to go find yours easily. One of the cool things I like doing is, and this has been around for a long time, is setting what we call the trace file identifier. If you set trace file identifier equals some meaningful piece of text, then that becomes part of your trace file name. It becomes actually a suffix to the trace file, therefore making it really easy to find in your trace file directory. The other nice thing with this is every time you change it, it actually closes the existing trace file with the old name and creates a new trace file. In that way, in one single long session, you could change the trace file identifier to pick up different parts of your application workflow. That helps you narrow in on just a particular part of a trace file you're interested in. A little bonus tip here is one of the good things now is a lot of the tracing information is now available from a view called $diag info. If you query that, it'll tell you things like your Oracle base, etc., etc. It'll also tell you the default trace file name. Now I've put the 3 little dots in there. That's just so it wouldn't fit on my PowerPoint slide. You actually get the fully qualified trace file name there. So if you're ever in a session and you want to know what your trace file name is, you just query $diag info. Number 5, too much trace data. Tracing is great if you can very accurately hone into where your problem is. But what if you've got a batch program that runs for 9 hours and crashes at the end? And you want to find out what's going on at the point at which it crashes. You don't want to have to sit around for 9 hours waiting till it's nearly done and then somehow turn the tracing on. We have this facility, which is what we call trace buffering. We do alter sessions at immediate trace file name, trace buffer on level, and that number there is the number of bytes of trace data to keep. And it's a rolling trace buffer. So what'll happen is, even if my program runs and does millions and millions of database calls, the trace file will only keep the last that many bytes of data. That's a megabyte. So it doesn't matter how long your tracing is turned on for, we simply keep the very last megabyte. So when my batch program crashes, I've got the last megabyte sitting right there. That's very useful. One last little bonus tip is, in the world of the cloud now, obviously sometimes we no longer get operating system level access to a lot of our databases. However, on certain environments, you can actually query your trace files using $diag trace file contents. Let me try that again. $diag trace file contents. You can simply spool that out to a file and then run tkprof locally on your own machine using the Oracle client to get access to the trace files even without any operating system access. Number 6, 19C. You would have seen in all the 19C hype this year and last year, one of the big banner line features was automatic indexing. And you've probably seen what are this little pentagon of things. Find workload, analyze it, create some sample indexes, see if they're better, lock them into place, and we go round and round and round. It's all very, very cool. But let's face it, most of us are only just embarking upon our journey to move to 19C, that long-term support release. There's plenty of people out there on 11.2, 12.1, 12.2, and 18. So until we get automatic indexing, these are the kind of challenges we face. Developers come to you and they say, I need a new index on my 6 terabyte table. And as DBAs, we may respond, is it going to speed things up? Because it's a big effort to actually put an index on a table of that size. And the response we often get is, I think so. Now, I'm not being critical here of developers who come back with this response. There used to be a time where we would be good to developers. We would actually give developers full-size environments in which to actually test and do performance testing, etc. Nowadays, it's a nightmare to be a developer because you have a 6 terabyte production table, and that same table has 27 rows in your development environment. And yet we say, make sure your code's going to perform well. It's an impossible task. So this is a totally valid response from a developer. One of the nice things is what we call virtual indexes, which is a facility to help us make a greater level of confidence about the decision about an index. I can create an index with this keyword which says no segment, which says go create the dictionary definition of this index, but don't actually go build the segment that sits underneath it. It's sitting there in the dictionary, but obviously is impossible to actually ever be used as an index. Because it's not really an index, I can't gather stats on it, but what I can do is generate stats on it, which simply says use the stats from the table and the columns of that table to come up with some representative stats on this virtual index. Then what I can do is, if I want to see if my query is going to use this index should it ever come to real existence, I can say alter session set use segment indexes equals true, and then run an explain plan for my problem query. If that explain plan comes back with, yes, I probably would have used this index if it really existed, that's that nice level of confidence. Because as we know, just because an index exists doesn't mean the optimizer is going to use it. Using no segment indexes is a great way of very quickly increasing that level of confidence to say, yep, I'm pretty sure that if I really make this index and go to all that effort, I'm actually going to fix this performance problem I have with this particular query. Number 7, let's talk about invisible indexes now. Virtual indexes are great at increasing that level of confidence, but they're still not enough to give you that guarantee that things are going to get better. Let me set the scene now with an example. I've got a table called T. It's just a copy of all objects, 50, 60,000 rows. I'm going to create an index called obt index because it's an index on the object ID. So remember, we have an index. The only index on this table is on the object ID. Here I have a table, which is an example from the previous example. It's a bad query. When I say bad, it runs too slowly for us. They're doing select where owner equals Scott, created is sysdate -1. We know the only index is on the object ID, so as you'd expect, it's doing table access full. This is that scenario where a developer then comes to us and says, can I put an index on the owner column in this case? And because they've been to my talk and they read about virtual indexes, you say, will it speed things up? And they say, I know so. I did a virtual index, I did no segment, I did an explain plan. I'm very confident it's going to make things better. So we go ahead and we create that index. This index is a new index, create new index on the owner column. Here's our problem query that used to do a full table scan. Owner equals Scott, created sysdate -1, and fantastic, it actually is now using this new index. The problem is solved. Bad query, full table scan, I put the new index on and it's running a lot better. We run around and we high-five ourselves and everyone's happy until the phone rings. Because here's the problem. Adding an index to your database is a massively risky exercise. Because what about everyone else's queries? Did we even think about looking at them? They may have gone to a brand new place after you've created that index. And let's explore that a little bit further. Before that index came along, here was a different query. It was owner equals sys and object ID between 10 and 8,000, for example. Because there was only an index on the object ID, it was using the object index. And when we ran that, it was about 784 consistent gets. After the new index, that same query has flipped over and started using the new index. Maybe that's a good thing, maybe it's not. And in this case, it's not. The actual performance has got twice as slow. It's doing twice as many consistent gets. One of the beauties of automatic indexing in 19C is we actually take care of this. We're very, very careful to make sure we never introduce regressions when we add these indexes. But as DBAs, we often don't do that due diligence. What we do is we say, there's a problem, slam an index on, and then we fight the other fires that come out later. Once again, we get upset users if all of a sudden their code just starts running slowly. The solution to this is invisible indexes. When I create a new index, I can create it or even alter it, as you see here, as being invisible, which means it's invisible to the optimizer. So here is that query that was using the object index and went bad when I created the new index. Now that the index is invisible, this code no longer sees it and still uses the execution plan it was using before I created this index. The developer who had the initial problem will, of course, come back to you and say, well, but if that index is invisible, what about my code? I'm back to doing a full table scan. I've come back to the same problem. One of the nice things with invisible indexes is you get to control when they're used. At session level, you can do alter session set use invisible index equals true, and now this query can see the new index. As a result, you can wrap your session, wrap your SQL to protect others. You know the new index is there, you can alter the session to pick it up. Other people will never know of its existence. There's also a statement level hint you can actually do, saying use invisible indexes just for this particular statement. In that way, you're protecting others from your indexes. That buys you time such that you can actually do a full suite of regression testing to make sure that index is not going to cause any problems elsewhere. Number 8, check my time here. Oh, we're doing okay. Better data guard use for free. Now, I want to spend a little moment here on data guard. Is anyone that doesn't have a data guard node backing up or sitting behind their production database, I think is crazy. And let me try to justify that. And I'm not just talking about disaster recovery here. That's the least of your worries because disasters are very, very rare. Let's assume you never had a disaster. You should still have a data guard database for every single production database. And here's why. I don't know anyone that has a single physical database server in their company. If they're running Oracle, they have at least 2 because everyone has a production and a non-production, dev, test, UAT, etc. Everyone has 2 or more. So they're already licensed. You've already licensed those boxes for the Oracle database. So wherever you have a production database, you should have a data guard version of that on your non-production server. It's not going to cost you anything in terms of licensing because you've already licensed those 2 boxes because everyone's got 2 or more servers. All it costs you is disk space, and disk space is dirt cheap. Think of what you then have. You now have a copy of your production database that is kept up to date in near real time, or even in real time if you want. Now you might be thinking, well, what good is that? It's stuck there in recovery mode. I can't do anything with it. That's what this tip is about. On a data guard database, you can do alter database convert to snapshot standby. What does that actually do? It actually breaks the link with its production source and opens that standby database read-write. Why is that suddenly an amazing thing to have happen? Now I have a copy of production that is up to date. It's frozen now. It doesn't keep being up to date. It's up to date as of when you broke the link, but it's a read-write version of production. I can test patches. I can test database statistics changes. I can test application deployments. I can test stress testing. I can test security. I can literally do anything that I would normally love to do on production, but can't because there's real users on it, on this second copy. I can do whatever I want to it because it's a fully read-write copy of production. This is a really common technique and it's really easy to do. At say 8 o'clock in the morning, convert to snapshot standby, which opens it read-write. Now you give that production database to your users. Use it for ad hoc reporting, use it for stress testing, use it for doing anything that you would normally not want them doing on production that might cause damage. The end of the day comes around, but now you've got a database that doesn't match production anymore. For a start, it's out of date, but also people might have been doing all sorts of things on here. But not to worry. You literally run these 2 commands at the end of the day. Convert to physical standby. What that does is when you opened up that database read-write, we took a restore point. You do whatever you want to that database, and then at the end of the day, it gets flashed back to that restore point. So it's now back in sync with the production database as it was at 8 in the morning. And then we do recover, manage, standby, database disconnect as normal, and it goes and applies the archive logs to catch up. and suddenly it's back to being a proper normal disaster recovery node again. It does a flashback to reset logs, but here's the cool thing. Even though you resume managed recovery 8 hours later, during that time when the database was out of sync, the archives were still being transmitted over. So your probability of data loss in the event of a disaster is very, very low. You're not going to lose 8 hours worth of data. You're actually getting those archives still being transmitted over. So it's very, very cool piece of technology. And as I say, it literally should cost you $0 because you've always got 2 or more servers already in your organization. Number 9, faster queries with no code changes, something that we'd all love to have. To set the scene here, I'm going to create a table of customer transactions. And as you'd imagine, customer transactions come in with a transaction ID, a date, and a customer ID and an amount. I'm going to insert 10 million rows here, and we've got 1,000 random customers. And as you'd imagine, rows always come in date order. That makes sense. Time goes on and orders come in as well. Obviously, one of the most common things that people want to do is see their own transactions. So I'll put an index on the customer ID column such that people can do queries based on customer ID. So here's a sample query from my application. Show me the highest money I spent on any transaction for my customer, which happens to be 123. And this is what they see. It's slow. Now, that's a bit of a problem because I've sort of done everything right here. I've got an index on that customer. I could add max amount to it if I wanted the amount to it, but the explain plan looks fine. It's doing an index range scan on customer trans. So what's the problem? Well, the problem is this. You can see that down in the statistics, I'm still looking at 9,000 physical reads to get that customer ID's details. And the reason for that is fairly straightforward. Customers don't do what we would like as database professionals. What they do is information comes in timestamp order, because that's the way the world works. Ideally, we'd like all the customer 123's transactions to come in at once. They'd all be nicely clumped together. But it doesn't. They come in scattered over time. Therefore, when you query for that one customer, you're scanning lots of different physical blocks on the database, scattered throughout the entire table. But in 12.1, we introduced clustering by linear order and also some interleaved stuff, but we can simply do this. I want to change an indication on the data dictionary telling the database that when I do a direct load operation or similar maintenance, I want the data sorted by customer ID. So running this does nothing to the data. It's simply a flag in the dictionary. But then I can do this in 12.2 and above. Move the table online. So I'm still taking in transactions, but because of this combination, the data will be reloaded in customer order. Now all the customers are clustered together based on their customer ID. Now when I run the same query, and probably this is the most common query in my application, same execution plan, much, much more efficient because all the customer rows are clumped together. Now, don't get me wrong, this is a trade-off. If I have other parts of the application that do queries perhaps not by customer ID, they may be impacted because the clustering has been now shifted to being based on customer. But the good thing is with this, you get to choose. What are the most important queries in my application? Are they by customer? I would cluster by customer. Are they by, say, timestamp? Then I would probably just leave the data as is because the timestamp information will be closely clustered anyway. But you get that choice. One thing I should stress if I flick back, this section in the documentation is right next to zone maps. Now, zone maps are separately licensed, but clustering by attribute clustering is not. So if you're running Enterprise Edition, you get this, you don't have to pay anything else. It's only zone maps that are the extra cost option. Number 10, DBMS X plan. How we got? We got 10 minutes left. Okay. Most of us use DBMS X plan in this simple fashion. Whether it's via a tool or whether at the command line, we run an explain plan, and then we do display plan. Or we might do display cursor for the last thing we just ran. However, there's lots of really cool extensions to DBMS X plan that we can exploit. And to show you an example of one, I'll cover what we call the infamous hint ignore issue, which is people say the optimizer ignored my hint. And here's an example of that. I'm doing a query on employee and department, and I get a merge join out of that query. And of course I go, I don't want a merge join, I want a hash join. So what hint do? I add use hash. I want to do a hash join. And what happens? The optimizer ignored my hint. And this is one of those things where we go, oh, this is a nightmare. Why do they ignore my hint? The answer is actually not that the optimizer ignored your hint. It's just the way the optimizer works when it's looking at hints. If you specify use hash D, that hint is actually interpreted like this. If I'm joining into the department table, table alias D, then I have to use a hash join. But we're not joining into the department table. We're starting with the department table and joining into the employee table. That obviously is a bit of a drama. Let me bring up my chat window here. Oh, where's my chat window gone? Lost it. Lost my chat. Oh, I can't see my chat, so I'm just going to hopefully ignore it. If we want to hash join into the department table, we need to start with the employee table. So the hint I need to specify is start with the employee table and then hash join into the department table, and it, yes, will then obey my hint. It's one of those things. The most common reason why the database seems to ignore your hints is you didn't specify enough of them. It's like, hints are like violence. If they don't work, try using some more. That's a joke, by the way. Let's go back to DBMS plan. One of the cool extensions of the DBMS plan is the fact that you can do plus outline. What that gives you then is your execution plan as per normal, but then it gives you the list of hints in automatically formatted output here that you would need to put to lock in that plan. That's the complete list of hints. And because it's printed out to you like this, you literally just highlight it, cut and paste it, and slam it into your query. And you fix the plan that you want. Don't get me wrong, this isn't something I'm saying you would go around and put that big list of hints into all your problem SQLs. But once again, in terms of emergency fixes, I've got a bad SQL, I find a plan that I want, I simply get the outline, paste it in there, and that gives me some time. That solves the problem initially. Now I can go look at actually either rewriting the SQL, tuning the SQL, looking at the physical design, or if I think I just need to lock that plan in forever, I would then use SQL Plan Management to make that into an accepted plan and make the bad plan a disabled plan. A little bonus tip, I'm just keeping an eye on my time here. The reason we generally say use SQL Plan Management and don't go around putting lots and lots of hints in your application is we get scenarios like this. Which of these 4 SQL statements has an incorrect hint in it? Is it this one, this one, this one, or this one? Well, in fact, all of them are incorrect. None of those hints actually work. They're all errors. One of the nice things when you get to 19C is you get another extension called the hint report, which will actually tell you if you specified hints in your SQLs, which one were used, which ones were not used, which ones were incorrectly specified, which is nice. That's something we've never had in the past. Having a number 11. Or we can maybe get to squeeze a couple more in. One of the most common things we do when we're exploring a new system, if we're having problems from user calls coming in, is finding bad SQL. But one of the most common issues we have here is that when we're trying to find bad SQL, we're running bad SQL to do it. And let me explain. This is one of my most common queries in my toolbox. I get called to a customer site. We're getting slammed with bad SQL. I go look for the bad SQLs, which is anything which is burning a lot of CPU, lots of high buffer gets. Anything which is being run an excessive amount of times maybe, might be a sign of bad code, or anything that's using a lot of disk reads. Any of these things are potential target areas. But I should never be querying $SQL, because to do that is to go hunting through my library cache. To do that is to take out a whole stack of latches that people now stops other people getting work done. You don't want to ever be aggressively mining $SQL because it could be doing more harm than good. You can do better than $SQL simply by changing that query to $SQL stats. Back in 10G, we introduced this. It's a separate memory structure that's like, think of it as a modified clone of the library cache. And the best thing is, if we read straight from the docs, it's faster. It's a different memory structure. It's not, you don't have to take latches. It's more scalable. When you query this, we work through a circular buffer of memory, so we never have to take a latch to protect it. It's a latchless structure, a bit like active session history, and it also has greater data retention. Things disappear out of VSQL when they get invalidated, but they will hang around longer in VSQL stats. So for vast majority of your queries against VSQL, this is a drop-in replacement. Just use VSQL stats instead. Number 12, SQL plus hashtags. And no, I'm not talking about Twitter, but I will say, please follow me on Twitter and you'll be able to tweet this tip. As I said before, I'm getting old. The memory's going, maybe one too many gin and tonics in my lifetime. So I'm writing queries nowadays against the employee table or any table in my system. And I know there's a column which tells me what kind of task this person does. Now, what is it again? Is it their assignment? Is it their role? Is it their job? I can't remember the name of the column. The problem is in things like SQL Plus and SQL CL, I'm sort of stuck because I'm halfway through writing this query now, and I normally have to abandon it and then rewrite it again. What you can do if you're stuck halfway through a SQL statement or anything in SQL Plus or SQL CL, might be just SQL Plus this one, is if you prefix something with a hash, you can actually run SQL Plus command. So I can literally do describe the employee table right there in line in the code. Job column. I knew it was called job or something like that. And then I just keep on typing. It didn't interrupt my SQL Plus buffer at all. And then it runs fine. This is perhaps the most common use I always do it for. I'm running a PL SQL block. I'm using DBMS output. And of course, I forgot to do set server output on. Rather than have to abandon that or save it in a file somewhere, I can simply do it with a hash command right there in the code and then run it. And out comes my answer. What's the next? I'm just thinking, what's my next tip? Next tip's a quick one, and then we're done. Lucky 13. Last one we'll get to today. SQL plus SQL CL transaction safety. By default, we've all been in this awkward scenario. I've typed in delete from really important table. I meant to type in where the primary key value equals, but I forgot. I just started running it. I got distracted. What am I doing now? Wiping the entire table. It's a moment like this, as an IT professional, you pause, you stay calm, you take a deep breath, and you think about your options. None of us do this. We see this and we go, we panic. And so what happens is we grab the mouse, we go, let's kill that as fast as we can. And just as we're about to click, it finishes. And when you exit SQL Plus or SQL CL by default, you commit. That is a career limiting move right there. I think SQL Plus 11 onwards both have this thing now called set exit commit, which simply by default is on because we have to preserve backward compatibility. But I put this in my login.sql for every connection I have, set exit commit off such that I always roll back just in case. That's my last one. Let's jump forward and wrap it up a bit. Okay, there's plenty more tips we could have covered, but time is against us. I'd love you to take all of these ideas and tips I've shown you and exploit them and use them to your benefit. I'd love you to share them with your work colleagues. And you certainly don't have to say you learned them from me. I'd love you to share them with your work colleagues and say, look what I know, and have them share it with their work colleagues. The concept of ownership of an idea, I think, is a terrible one. It's a selfish one. We should be sharing these things always. Hopefully you've learned something new, but in particular, the great thing is here is if you take these tips and use them on your systems, the best thing is we all learn something new because you'll use some of these tips in a particular way, find some particular edge case, and you'll pass that back to me at the next time I'm at some sort of user group event. And therefore, I can take this and then share it with my work colleagues. That's the important thing. Before I finish off with this last slide here, I will say one last thing though, is notice here that this wasn't a formal presentation as such. We didn't cover one topic just the whole way through. These are lots of little tiny things just I've picked up over the years. Hopefully you found it interesting, but also it demonstrates hopefully to you that if you've ever thought about, I don't really have enough information to do a full talk or a full topic or run anything or contribute to my local user group. Well, you don't need to. It's really just sharing your experiences. And I can't stress enough, now is the best time. If you've never shared anything at your local user group or local meetup, it's the best time to get started because generally it's going to be done virtually. So there's no fear of if you don't want to stand up in front of a group, you can do it over Zoom or go to webinar. So it's all done in the safety and protection of your own office or own home. So it's easy to do. It can be a 10-minute thing, it can be a 20-minute thing, but the more we can reach out and contribute even the most trivial things to our community, I think the more we all benefit. So with that note, I'll stop my share and hand back to Thomas. Thank you very much for giving up your time today. And yeah, basically, if you have any questions, you can fire them through. If you'd rather not ask them to me directly, you can always reach me on Twitter and I'm happy to take your questions there as well. Back to you, Thomas.
Thank you, Connor. That was really cool. I just calculated 252 slides shown in roughly 45 minutes. That's not bad. Thanks for sharing these little tips and trips. There is something that we should also consider. It's that was not just DBA talk, huh? You're talking also developer. Maybe when you enter now into the Q&A, everyone can raise his voice. Maybe you start introducing yourself briefly when asking a question to Connor. Say, what's your perspective? Are you now carrying the DBA role, the developer role, or something in between? So that we understand on what your starting position is. Why? Because the same problem looks different from different perspectives. And share that with us in order to get a good answer.
And I will also add, if you're sitting there going, I've just been slammed with 200 plus slides, I just need to lie down and not speak to anyone for a while, that's totally fine as well. If you don't have any questions, I understand. I do talk at a fairly rapid pace, and I have nothing but respect for the audience where often English is not the first language. Blows my mind, the multilingual society. So if you don't have any questions, that's totally cool as well.
So for anyone, if you want to raise a question, just use the chat or just raise your voice. We just open up the line for you. Just as a starter, I might start so that you can see that he really answers questions. There has been so much talk about indexing, auto-indexing. So why should people still think about it? Why should we have these different communities of people saying, I want index A, index B, index C, the precedence of indexes as well as triggers? I mean, there should be equal opportunity for everyone. So why use it at all?
Okay, I'll come back to that because I'll do the right thing and answer the question that someone has been brave enough to put in the Q&A. For the trick with the standby, do you need active data guard license? No, you don't. Active data guard is only if you want to have your database only read only and being actively recovered at the same time. The convert to snapshot standby I spoke there is just stock standard standby database, no additional license fee besides your standard data guard enterprise edition license. And as I said before, I would argue that you can always have a data guard node for zero cost because you've always got more than one server. To answer your question, Thomas, it's an interesting one. I'll answer that in two ways. One is I'm a realist. I know at Oracle here, we're often criticized because we talk about 19C and 20C and 21C, and people say, yeah, that's really interesting, but I'm on 11.2. I'll be on 11.2 for the next decade. My manager's going to learn about 12.1 in 2031, etc. So while automatic indexing is very cool, I understand that, I fully accept that a lot of people won't be on it for some time to come. And even when they get to 19C, they may not be on a platform that supports automatic indexing. Having said that, one of the cool things I think is with automatic indexing is what it does is it takes away the risk factor for DBAs. One of the things that I think is often misunderstood is the massive amount of risk of adding an index to your system. Because the reality is we would all like to think that before we add an index, we would carefully look at every single query that could potentially be affected. But let's be honest, none of us do that. What we do is we have a problem, we solve it with an index if we can, if that's the appropriate action, and then we fight the fires that come afterwards. That's one of the benefits of automatic indexing, is it works very, very hard to try avoid performance regressions. And one of the nice things with that is it then lets us be perhaps a little bit more aggressive with indexing. And don't get me wrong, I'm a big fan of as few indexes as possible. My mindset is I treat indexes as a bug. Now, I know that sounds weird, but I view an index as being a bug in the technology. Because if every full table scan took a nanosecond, none of us would use indexes because it would be fast enough. So my mindset is always, I'll always put an index on, always effectively as a last resort, because that way the less indexes I have, the less, that's my dog come to say hello, the less indexes I have, generally the better performance I'll have. So I always say, my view is you need just enough indexes and not a single one more.
Thanks, Connor. There's a good question by Jörg about trace files. I mean, rolling trace file sizes equally relevant for SQLnet traces, right? Is it available?
Unfortunately, I don't think so, because I think it's actually controlled through the client when you're doing SQLnet tracing. I haven't tried it, but I'm pretty sure it's only for database standard database tracing. But that's an excellent question. Let me make a note, because I will give that a go and see what happens if my dog lets me type on my keyboard. Yeah, because I take your point. If you ever turn on like trace level 16 for a SQLnet trace, it gets big fast. So.
A suggestion. I mean, you're sharing your slides anyway through your blog, right? So what if you just add this tiny detail and let the community know when this has happened, so that we have an idea?
No problems. And for anyone on the call, yes, these slides, I'll send them off to the user group such that they'll be made available to you. That's no problems at all.
Okay. Yeah. So any other questions, either verbally or in the chat?
This is Clement speaking. Just for organizing the next session, I think we have to stop here so that Elisa can set up her, environment. Okay.
Yeah. Having said that, thank you very much, Connor and best friend. We love you guys, and stay safe, stay cool, and see you next time.
Thank you.
Thanks for your time, everyone. Have a great day.